John Bushy with American Standard Circuits here. In this segment, we're talking about copper roughness. Traditionally, when we talked about the treatments that were on the backside of the copper that was adhered to the resin or the dielectric surface of the material, we were talking about electrodeposited copper. Generally, it was a very pronounced, very rough surface finish with its main goal being adhesion to the laminate system or the resin system that it was adhered to. How it was traditionally formed, or how it is formed, these large tooth structures, is basically building a series of nodules or dendrites on the back side of it. And basically what it ended up having is a very rough profile. Even in these areas that it looks like there's no tooth, there's actually still a stack of these little nodules, so to speak. It increased the surface area, it gave you great adhesion, but one thing it did is it also degraded the RF performance, particularly at higher frequencies. That created the advent of what were low profile, very low profile, and what is becoming even more common today, ultra low profile copper foils. What they've done is been able to reduce the roughness on that backside using proprietary methods, while still maintaining the adhesion to the substrate in order to meet IPC specifications for peel strength. This is increasingly important when we start talking about outer layers, where there's going to be components or fairly heavy devices attached to these circuits. One of the latest advents is almost no profile copper. This starts to play in a realm that used to only be in the ultra high performance, ultra high cost, rolled annealed copper foil territory. Rolled anneal had several advantages. It was formed in a rolling method, which created a laminar grain structure, which is opposite or in line with that of the electrical signal traveling through it. Electrodeposited copper foils tend to have a very columnar structure, which is counter to that. The ability to be able to reduce the roughness, increase the surface adhesion between these almost no profile coppers, has allowed us to use a material that's fairly low cost, roughly equivalent to these other forms of electrodeposited copper foil, while achieving most, if not all, of the performance you can get from rolled annealed copper foil. Needless to say, rolled anneal is still preferred in some of the ultra high frequency applications, but for the cost, almost no profile is of huge benefit.